Sabre, Team Sabre. I am Hunter Ross.
I'm Mary Liz Tuttle.
And I am Ramon Trespalacios, and before we start, we would like to thank Ross Darrow for coming. He's our client and helping us throughout this process. So thank you for coming, and we hope our proposals and results can help Sabre.
So the problem that we were looking to solve for Sabre was we wanted to provide ticketing segmentation services for their customer reservation system in hopes that we could provide some marketing solutions or marketing strategies for them to use. So what's a cluster? Well, a cluster is a cluster. It's a group of something. It's a bunch of something. And that's what we were looking to do with the data that we were provided with. We wanted to classify it, or we wanted to cluster it, and then classify it. So the method that we chose was k-means clustering, which partitions the data into n observations within a certain number of clusters. And it partitions each observation to a cluster in terms of the nearest mean. So here are some use cases that give us some examples of how segmentation leads to solutions. So the first example as shown here is, so let's say an airline creates a specific fare product that they want to reach a specific market. Well, segmentation shows us if they're accomplishing that goal. If, let's say, segmentation leads to different demographics, like 30% leisure, 40% business, and 30% other. Well, then this segmentation is showing us that perhaps the product is not as well specified as they had hoped it to be. So this leads us that good segmentation can provide insights into the design of goods, good fare products up front. And what we hope to do is conduct breakdown analysis of various fare products by post-booking and pre-booking segmentations. The information that was given to us initially was ticketing information, ticketing data, and might add a lot of it. There was about 2.5 million tickets that were given to us, and it was over 14 days of ticketing. And within this large CSV file, each ticket represented a row, and each column was represented by a variable that described each ticket. And here are some of the variables. They range from booking date to return date to travel time, inbound and outbound, and so on and so forth. We were also provided with a sample R code that helped us segment our data initially.
So with this information given, what we intended to do is cluster all these data with the k-means clustering and create a set of rules that create a unique category for any given tickets, along with our report showing validation efforts. Our report will also describe the techniques used, pros and cons, and rationale for the final recommended set of rules. So whenever we did the code and we put all the data in it, we received a table with 6 different clusters, and each row had different numbers. Some of them were interquartiles, range from the mean, and others were just percentages. Mary-Liz will expand on that later. The methodology we used k-means clustering in the program R, which is a statistical program. We found the optimal number of clusters. We also interpreted the output and then used subjective analysis to categorize them and determine any conclusions. To choose our optimal number of clusters, we did a lot of things, but first of all, in the R code, we created a graph that compares the number of clusters with R squared. We learned that if the increase from one cluster to the next is big, then that means that the clusters will have enough differentiation within each other. But if it starts reducing and reducing, as you can see, it starts plateauing. Whenever you increase from 6 to 7, for example, the differentiation between each cluster is not going to be that significant. Therefore, we realized that from 4 to 5, there's about 0.05 differentiation, and then from 5 to 6, 0.025. But if you continue through that, it starts going to 0.01 or less, meaning that we chose 6 as the optimal number of clusters. Other things we did is just try it out and produce tables for 9 clusters or 3 clusters, but we realized whenever we had 9 different clusters, 3 or 4 of them were exactly the same. So in reality, it didn't show that it was a good cluster.
So for post-booking classification rules, we did post-booking and pre-booking. So I'm going to go over post-booking and Hunter will go over pre-booking as well. So we created a set of rules to help classify the clusters. So first we looked at the variables such as advanced purchase, length of stay, fare, and then inbound and outbound travel times. And then we looked at those and determined if they were above or below the mean to then draw conclusions. So for example, if it had a higher, than the mean for advanced purchase, then they purchase it a little ahead of time compared to others. And then we looked at the return day of week and departure day of week, as well as the agency type and the number of travelers. And we found the most popular variable in those categories. And then we looked at the Saturday night stay dummy variable to see the percentage of like how many people were staying the weekend. So for example, on the next slide, we have cluster 1. So it's the last minute single business traveler. So we came to that classification because it had a lower advance purchase number, and then it had a shorter length of stay, a more expensive fare. They departed on Monday or Tuesday and returned on Thursday or Friday, and then they used G Corp as their travel agent, and it was mostly a single traveler purchase. So then we decided it was a last minute single business traveler from all that. And then we had, for cluster 2, we had extended stay leisure traveler because it was a longer length of stay, higher advance purchase. We say any day travel because the departure and the return date of week were pretty spread out among all those variables, because we had departure date of the week being Tuesday, Wednesday, Thursday, Friday, like every day of the week, of course. And then 75% of those stayed Saturdays, so that's why we came to the leisure conclusion. And then this is the more affordable business traveler because they had a longer length of stay, long in and outbound travel times, perhaps layovers or to get the cheaper fare, and it was purchased well in advance, we noticed, and only 35% of them stayed Saturdays. And then cluster 4, we had planned vacation traveler, so that had a higher advance purchase rate, and then short length of stay, cheaper fare. 25% returned Sunday, so we were thinking maybe like they were planning for a Thanksgiving vacation or a Christmas vacation, and it was during the week and they had to return Sunday before school started or something. For cluster 5, we named this one the recurrent business traveler, possibly a consultant who leaves Monday, Tuesday and returns Friday, books through G Corp and G Online mostly, and 89% were single business travelers, and only 30% stayed Saturday nights. And then for cluster 6, this is the quick trip business traveler, because they depart Monday or Tuesday and then they return either Wednesday or Thursday. So short length of stay, always booked through G Corp for the most part, and 93% single.
So our pre-booking classification rules are the same as our post-booking classification rules, except 3 things. We take out 3 variables. We take out the fare, the outbound travel time, and the inbound travel time, because we just don't have that data because it's pre-booking data. So for cluster 1, we determined that it was a leisure weekend traveler, and I think 3 variables stood out to the most for us to determine this classification. The first is the advance purchase. They're purchasing it well in advance, and most leisure travelers do purchase well in advance. It's not common for you to travel on vacation if you're booking it the same day. The second variable, or the second aspect that led us to it being a leisure weekend traveler, was that they were staying on weekends. They were usually departing on Thursday or Friday and then coming back on Sunday or Monday. And then also the main factor that led us to it being a leisure weekend traveler is that 96% of these travelers, this cluster, were staying over Saturday nights. The second cluster was also a leisure traveler. They had an increased advanced purchase date, so they were also leisurely purchasing in advance, planning out their vacation. They departed any day. We couldn't really define if they were leaving on Monday or Tuesday or getting back on Saturday or Sunday. And 85% of them stayed over Saturday night, while 80% of them were single travelers. The third cluster, we classified them as holiday or vacation travelers. Again, they purchased well in advance for their leisure trips, and they had a long length of stay. We couldn't really identify when they departed, so they departed on any day of the week, and most would return on Sunday. 50% of them stayed over Saturday night, and the reason we were able to classify it as a vacation traveler or holiday traveler is because the demographic was spread across being a single traveler, 22% being couples, and then 11% being family travelers.
Cluster number 4, we classified as a week-long business traveler. The reason being that they purchased it in average in advance, and they had a long length of stay. They also departed on Monday and returned on Thursday and Friday. All of them were booked through G Corp, which is a global corporation. And then only 0.03, so basically nobody stayed over the weekends, and they traveled by themselves. Then cluster 5 and cluster 6 are actually pretty similar. So both of them are quick trip business travelers. In this one, it's again the average advanced purchase. It departs on Mondays and Tuesdays and returns before the weekend. But these ones are purchased through agencies, FSC, and unclassified. They did not see on Saturday either, and it's 93% single. And cluster 6 is basically the same description, with the exception that they're all purchased through G Corp. So basically we went through different clusters, and next time that you go booking something online, see where do you fit, because in reality that will affect the way your fare will be priced and different things. So if you saw something that ticked your brain, or like you're going to become a consultant, maybe you fell into one of these clusters. And now Mary-Liz will tell us the proposals.
So we propose to use post-booking clusters to offer discounts or premiums in post-booking services, such as hotels and other reservations. For example, in cluster 5 we had the recurrent business traveler, possibly the consultant, who might like to receive a discount in airport lounges for being tired from traveling all the time, or maybe like partnered hotels. And then we propose to use pre-booking clusters to choose a more appropriate fare targeted to each cluster specifically. So for example, cluster 3 was a vacation traveler, and they would probably prefer to pay a cheaper fare because they book farther in advance. So maybe a special like 3 or 4 months in advance before a holiday, so they can plan accordingly.
And this brings us to our conclusion, and we really think that our clustering and our rules on how to classify the clusters will help Sabre in the future, and they could use these recommendations to implement them in their different ticketing data. And thank you for coming and listening to us. You know that here at SMU we're world changers, and we've been shaped here. Are there any questions?
Ross, did you have any?
No, I thought it was very nice. Matter of fact, I've been meeting with some of the people in the Airline Solutions Division next week to talk about this.
Awesome.
Well, what was the biggest challenge on this project for y'all?
I think definitely, well, there were a lot. The first, the learning curve of the programming, the our program, we had no knowledge at all. So it was really good to have a resource like Ross to guide us through it. And now we feel like at least we understand it, so we're able to read it. So that was a problem. And then I think the second one we had was figuring out the amount of clusters that was optimal. We were just trying with all of them and seeing which one was the best, and it took us a while to understand why 6 was the optimal amount of clusters for our data. What about you?
Well, I could say one problem we didn't have was meeting with Ross, who was always available to meet with us, and he took so much time out of his day to help us every week, and so we really appreciate that too.
You're very fortunate. Not everybody has that experience.
You're the best client ever.
Questions?
Yes, I think there's a question.
Yeah, what's the difference between pre and post booking?
Oh, so post-booking is after you buy the fare, so then you have the fare like price and the inbound and outbound travel time. So pre, we left that out.
So you know when you travel, sometimes you just search for different flights, or you reserve them, but you don't pay for them. That is pre-booking. But once you've purchased and you've done all of that, that would be post-booking. You've traveled. Like pre-booking, you maybe have not traveled. There might be a delay or something.
I don't know if I'm understanding the pre and post booking right, but do you know how many percentage of pre-bookers become post-bookers?
That data was not provided to us, but probably Ross knows
For
that.
something like Trespalacios is about 3% or less.
Okay.
For when you go into a brick and mortar travel agency, it's reasonably high because.
And they're doing it on
Yeah.
the site.
Or if corporate travel agencies, it's fairly high because you're intending to travel.
Okay, instead of just
So
browsing.
if your company uses American Express, it's affiliate. You call them up, you're going to get a booking.
Yeah.
Well, great. Well, thank y'all very much.
Thank you. That was fun.